Okay, so welcome then to the session called Looping Abreast. My name is Erland Sommarskog. I live in Stockholm, and you have my email address as good as Sommarskog as E. So we know that, let's see, yeah, we know that set-based code, that is what we want to write. Loops are evil. However, every once in a while, we encounter these problems that actually kind of scratch our head. How do we actually solve this set-based? It's kind of difficult. Or we can think of a set-based solution, but we realize they're inefficient because we have to have subqueries and all sorts of stuff. Because quite typical for these problems is that we realize that just mentally, we could solve them with a single pass over the data, but we just can't seem to express that in SQL. So yeah, we have to raise the white flag. Okay, I'm going to write the loop this time. To compute the result for one customer or one product or whatever it is, I need to loop over that data for that customer. Now, does this also mean that I need to loop and compute the data one customer at a time? No, we can loop over the customers abreast, do them all in parallel. And that's the topic for this session. We're going to work with something I call the Christmas presents problem. So we have an order database, and every time a customer is bought for a total of 1 million, they're entitled to get a Christmas present. But there is a rule that makes things complicated. When they get past the limit, they restart on 0, no matter what the excess amount was on the last order. So let's say they have placed orders already for 950,000 and place a new order for 250,000. No, they will not start on 200,000. They will start on 0. And this makes it kind of difficult to write a set-based query. If you can think of one, please drop me a line, and particularly if it's efficient. But there is also one more rule, and that a customer cannot earn more than 10 Christmas presents. That's it. So first, we're going to look at a solution which is just a simple-minded loop, one customer at a time, so we get an understanding of what I'm talking about. This database, the demo database for today, Looping Abreast, you will get a link at the end. There's, I think, in total 1.6 million orders, and we're going to work with the year 2018, for which there are 250,000 orders. And I also got a variable which has this limit of 1 million and the max presents. I got to call this one the Christmas limit. And this max presents is the 10 number of presents. I got some looping variables. So the current customer, the amount for the current order, the cumulated sum for that customer, and the number of presents awarded to that customer. And I also got some variable to take the time of how long time this has been running. And I got my results table, hash presents, where I have the customer ID and the number of presents for that customer. So then I first start setting a precursor for overall customers that have placed orders this year. I'm just doing that for my orders table directly. And then getting the customer ID, clearing the cumulated sum and the number of presents is 0. Setting up a nested cursor for this customer for all the orders, going by order date and order ID. And getting the order amount into my variable, increasing the cumulated sum with the order amount, check that against the Christmas limit, and if I'm beyond it, above it, increment the number of presents and slash back the cumulated sum to 0. And if I have reached max presents, well, let's just quit this customer. And then finally, if I did award any presents at all, record these customers into this table. And then what to do here is just how long time did this take, and I'm returning also the total number of presents I awarded. So let's run this to get a baseline for this test. This takes a couple of seconds. Yeah, it took, well, 6.5 seconds to do this. So let's see if we can do this better by looping abreast. Let's see, that's one. So the general technique for doing these looping abreast things is this. You compute a batch number for the transactions with a row number function. This means that the customer's first transaction will be in the first batch, the second will be in batch number 2, etc., etc. It also means this, that if the customer has 10 transactions, well, the customer will not be in batch 11 and on, and etc. Then we materialize this numbering in the temp table with a batch number as the leading key in the clustered index. That's very, very important. And then we loop over the batch numbers and perform the computation one transaction at a time for all customers abreast. So let's look at this solution. So again, I got my year and my Christmas limit, my max presents, but no looping variables this time. Instead, I got my temple hash batches, the batch number, the customer ID, and the single piece of information I need in this example, the order amount. And note here, the primary key has the batch number and the customer ID, and that's also the clustered index. Again, and I fill this one up with doing for all the orders this year, the customer ID, well, the amount for the order, and doing the row number, partition by customer ID, order by order date, and order ID. Then I got my hash presence table, which now is slightly different. It's now kind of a work table as well, a work area as well, not only a results table. So I got a customer ID, I got the accumulated sum for that customer, and the number of presents awarded. And I fill it up with all the customers that are in batch 1, because all customers that I'm going to work with will be in batch 1. Well, then I set up a cursor over my batches table, getting all the distinct batch numbers, get the batch number, and then I'm going to do an update on my presents table. And first look at the join here. So I'm joining presents with batches on the current batch number, and I'm joining over the custom ID. This is very, very typical pattern for these looping abreast things. And I take the accumulated sum, check it against the Christmas limit. If I'm below it, I'm just increasing it, else I'm slashing it back to 0. Number of presents, well, if I'm below the Christmas limit, don't change the value. If I'm below max presents, increment by 1, else stay at max presents. And then there is a small optimization here. So I'm checking the current batch. Is there any customer now that has not been awarded max presents? Because if all customers that are left have reached max presents, we are done with the loop. There cannot be any more presents to award. And then I do the same thing at the end, getting the execution time and returning the total number of presents. So let's try this and see if we can beat the original loop. Indeed, we did quite a bit. We were almost, not really, well, maybe even a factor of, well, between 2 and 3. Now, that was the general technique, is to use the hash batches table, and you can always do that. However, sometimes you encounter problems which offers a built-in iteration column. Quite often that is a date, but it could be something else. So let's make a twist to our Christmas presents problem. After the customers have earned a present, it takes 10 days before they can start earning a new one. Because why we do so, it doesn't really matter. But it does seem that, oh, this makes the problem even more complicated. But as a matter of fact, it simplifies the problem, because now we only have to consider the standing at the end of the day. We don't need to number the transactions. So again, I got my looping abreast table, I got my year, my Christmas limit, my max presents. I also got the waiting period, my single loop variable, which is the order date. Again, I got my hash presents table, but no hash batches this time. I got my hash presents table with the customer ID, the accumulated sum, number of presents, and now also the date for the date the customer most recently was awarded a present. And I'm going to do a loop, and I'm thinking I don't need even the cursor here, because I probably got orders most days of the year. So I'm just going to start at 1st of January and do 1 day at a time. And I will do a merge on my presents table using this as the input source, computing for today, or the order date, the total amount for each customer that made orders on this date. And new customers, well, they will end up in this not much by target, new customers for the year, and I'm going to insert them to the table. And then I have to consider the fact that they may actually have placed orders on that single day above 1 million. If they have not, well, then I'm just going to initialize the table entry with the day amount for the accumulated sum, the number of presents is 0, and latest presents to some date way back in the past. But if they were above 1 million, well, the accumulated sum is set to 0, the number of presents to 1, and the latest presents is set to the order date. And, well, if it's a recurring customer, well, that it's when matched, I add an initial filter to make things more efficient. So I'm saying if it has to be below 1 max presents, and they must have gone past their waiting period, the difference between latest present and order date. So, and then same thing, accumulated sum, either as in increment, or if I'm above Christmas limit, slash back to 0. Number of presents, either increment or retain, depending if I'm gone past the max limit, and latest present, either retain or set to order date. And the last thing I do is just to simply move on to the next day. So let's try this, see if this might be even faster. We can expect this to be faster because, and it was, because we don't have the overhead of filling up the batches table. So that was the end of the loop. My name is Erland Sommarskog. My email address is sql@sommarskog.se. And yes, I'm very much appreciate if you have questions about this session. You're more than welcome. You find slides and scripts on my website, sommarskog.se/present. You find the scripts, and there's also in the download kit. You will not get the database. There is a separate link for get that one. It's kind of big. It's 1 gigabyte in size when you have expanded it, and the download is 80 megabyte, and you need SQL 2016. And with 30 seconds to go, I think I'm done. Thank you very much for listening.